Hey guys, so my name is Sasha. I work at Gotham Digital Science. I'm a security consultant and have been for the last 4 years. I say probably 80% of what I do is web application tests. A good 80% of those are black box tests. So an extreme example of a black box test, we had a client turn around and say, we're not going to tell you whether your web application is. We'll tell you what it's like, go find it, confirm with us that it's what you think it is, and then proceed to hack it. But typically what it means is that we get given some credentials and we escalate our way up the exploitation path to some kind of system compromise. So for the last 4 years I've been performing black box tests, and it's become quite obvious that black box tests are kind of a hangover from the era where we used to hang out in our basements and test things not necessarily with permission. The problem with this, it's quite obvious after a little bit of testing that we are largely testing blind. A lot of what we do is inference based, so we inject some kind of input into an application, it will give us an output, and we'll try and come to some conclusion as to what's happening behind the scenes. So the solution to this has been grey box testing. So a client will provide us with source code and say, look, perform a source code audit and use it to better channel your black box testing. So this combination, we get a kind of grey box somewhere in between kind of test. It's slightly more informed than black box testing, but it can be problematic. A lot of the time we are chasing source code with clients. We can spend a good 2-3 days burning time trying to find the right developers, different development teams. When they do get the source code to us, it's not the right version, it's not what's going into production. Problematic. And then trying to find the one guy in an organization who knows actually how to build this solution is, well, it's never happened. So if we aren't provided with libraries, we're chasing our tails a lot of the time. So yeah, we also got a problem with source code delivery. Obviously, most of this source code is intellectual property that a client does not want to leave the site. They don't want to send it to you via any kind of external means. So it has been a problem trying to get a hold of this stuff once on site. So what's the other grey box solution? It's, well, I think it's probably using runtime tracing technology to skip past this source code necessity and actually have a more informed look at what's happening whilst we're performing these tests. Typically the tools that, well, a short summary of the available tools are dtrace, ltrace and strace, and they are kind of in order of preference. If you've got a box that you've got dtrace on, you've lucked out. Well, do some research on the tool, it's fantastic. It not only allows you to monitor function calls as they're being performed, but you can also edit them via its destructive mode. ltrace allows you to trace library calls. This is convenient for libc style calls, so whenever you want to spot like a dangerous memcopy or evaluate a memcopy or stir copy or any kind of dangerous function, you can use that. And strace is kind of your fallback mechanism if you've got none of these things. So if you think about something like a remote file include or local file include, let's go with local file include. So the easiest way to spot this would be to watch for a syscall open on a file handle, and if the argument for the path argument ends up being some kind of data that you control, you know that you've potentially got a vector for a file include of some sort. So what does typical testing look like? Number one, we issue a request, a HTTP request. It hits a web server. That web server says, well, it's querying username.php, so I'm going to perform a syscall, open that file out, read the contents out, and pass that source code to an interpreter and execute whatever code's in there. So let's say that contains a SQL select statement. The web server will handle the query in the database via whatever function calls it does, and then we get returned some HTML based on this query and the response from the SQL server. So tracing effectively allows us to interject into a number of these points so that we're not only pumping data in and getting some kind of output out, we could actually sit on the web server and say, every time a function call is made to the SQL server and a SQL query is performed, tell me about it, so that I can have greater overview of how this application actually functions. Every time, like we mentioned, a syscall is made to open a file, tell me about it, because I want to know if I can control any of that input. So I mentioned some of the tools already. dtrace is Solaris, FreeBSD, OS X, and iOS simulator included by default. So if you've got OS X, start playing with dtrace, because it really is like incredible. ltrace is commonly included in Linux and Unix distros, and as is strace. If it's not, you can sort of get it via package managers quite quickly. strace truss, so they leverage the ptrace syscall. The ptrace syscall effectively allows a process to gain control of another process and mess about with its internal state. This kind of allows us within strace truss to log syscalls as they are made by a application. And how to describe syscalls. So syscalls are basically like the operating system level API. So if you want to open a file or do some kind of repetitive task that's just too monotonous to do manually, you leverage these APIs. So the equivalent in Windows is the Win32 API or the extensions for 64-bit. The difference with ltrace is it allows you to trace library calls. Again, if you want to look at things like buffer overflows and seeing whenever a dangerous function in libc is being called, you can leverage ltrace to give you this kind of printout of all this stuff going through. It also includes monitoring for syscalls, logging for syscalls, so ltrace beats strace always. dtrace, dynamic tracing, was developed by Sun, included in Solaris mainly as a kind of performance logging and troubleshooting tool, and it's fantastic in that it allows you to step through applications that have probes defined within them. And this is a bit of a holdback in terms of you have to have an app or some kind of service that's had these probes coded within them. Once you've got these, you're actually flying, because not only can you monitor function calls, you can actually modify them on the fly. So you've got a quick route into in-memory fuzzing and process fuzzing, that kind of thing. What dtrace looks like in action. So QN is effectively quiet mode, dtrace, and then the red bit is a target process. So we are looking for a MySQL daemon. We're looking for a query that's wildcard MySQL pass. MySQL pass is what MySQL calls every time it wants to perform some kind of select, insert, whatever statement. Bits in blue are what we do once we have triggered this condition. So we want to print out a timestamp and the first argument to the function, to MySQL pass. And then we're just grepping out and piping back the PID for MySQL service, MySQL daemon. And the output kind of looks like this. So what you have is, this is from PHP MyAdmin. You have every single query that is performed once you hit a page. Now it's typically a lot more queries than we'd think occur in the background. So the target really is to look through this and attempt to find something that we potentially control. That could be an attack vector. And right at the bottom we've got a select B-size 2014. So it indicates that we might have some kind of control of the parameters passed to that select statement. Therefore, we might have SQL injection. But this is very applicable for Apache kind of web appy kind of testing, which is what I spend a lot of my time doing. So I've kind of focused my research into these tools based around those facts. But there's no reason that you can't use these tools to perform just a system-wide kind of blanket coverage of every dangerous function that is called on your system, what's calling it, and even set to the side so the expected buffer size for the arguments and the actual buffer size. So it's quite easy to trigger an alert every time you get some kind of buffer overflow condition. This is on OSX. Again, OSX kernel includes the probes that you need to be able to perform this kind of kernel level logging. Okay, we've got SQL injection, we've got buffer overflows, and a massive issue, or one of the hurdles with how we progress to perform black box testing, or this sort of grey box testing style, is we need to define what the heuristics are for different vulnerabilities. For example, how do you perform cross-site scripting assessments automatically, programmatically, using tracing tools? It turns out that Firefox is actually contains a lot of the dtrace probes. You just have to build it separately with a separate flag, and you might have an avenue there for hooking into the JavaScript runtime and seeing if there's any data that you're passing to it that you can control. Or there are simpler avenues, like every time an application or web server returns some outputs, every time it's writing to a socket, is it writing any data that we've put in there? This idea of monitoring the data that we've put through ends up being actually quite key to how we analyze these large data sets. So if you guys use Burp, it's a scanner. You'll see the tags that it generates. They're kind of like hashy, ASCII kind of values that append to different queries, so that it knows which requests have ended in which responses for second, third order cross-site scripting and that kind of thing, so it can match request-response pairs. You'd have to pursue the same kind of avenue, so you have to match on token values in vulnerabilities, and then say this request has a value to this kind of response, which means that probably we've got some kind of cross-site scripting, or at least a through route to some kind of vulnerability. And this is something that needs to be considered actually with all the vulnerability classes, is how do we utilize these tools? At which point do we evaluate the vulnerability and that it's successfully occurring? And how do we meaningfully reduce the data set? So using dtrace or ltrace or strace, what I've got at the moment is a client agent and a server. Agent talks to the server and it says, look, I've got all these syscalls and it's in the tens of thousands, and your terminal buffer will quite quickly fill up because the data set is actually massive. So you have to be a little bit smarter about what you want to monitor. So you have to start reducing things like syscalls down to pertinent syscalls, so file handling syscalls, anything to do with the network. If you're at the sort of WinAPI level, are we calling any cryptographic APIs? How are those being called? And then depending on the SQL Server database types and web server flavors, you're going to actually have to hook different things. So there's a kind of learning process to employing this technique. And then there's more sort of nebulous concepts, like how do we test for authorization weakness? That's quite tough. That's a hard problem to solve in this kind of scenario. But I don't know, some more thought might come up with a solution. The issue of how do we then quantify and guarantee coverage? So how do we say to a client, we've hit 80% of the functionality within this application, and it turns out that that's not quite an easy thing to do. And there's a dependency for the client to A, give us access to the server that's running these services, B, that they've got the tools installed, or they will allow us to install these tools. Because a lot of the time we tend to test in development environments, this isn't too much of a hurdle. You just have to talk to the right developer. They're quite happy to give you access as long as you don't completely tank the environment. But the overall benefits are that really I get a little bit less bored by constant web testing day to day. I get to think about things on a different layers, which is quite important. So my generation got thrown into web app testing, and we didn't really escalate up the stack like people that started with networks and then worked their way up. So we're kind of merging our way down. We're traveling down from the application layer all the way down to the physical stuff. And this is quite a beneficial way to learn all that kind of stuff and learn how things function behind the scenes. The obvious benefit is this removes source code dependency, so if you haven't got source code at the time, you've still got some kind of grey box, more enlightened view as to what you are testing. More bugs is obviously equivalent to better coverage, hopefully, and tracing is bigger than web apps. Alright, so I've restricted this to web app testing, but there's absolutely no reason why you can't do something more sophisticated like network security tests. A big bugbear I have is RPC services, and I never feel like they're adequately tested. However, if we can sit on the same box as a service, monitor the kind of critical calls that are being triggered within it, what we can do is get a better idea of, well, how we should proceed with testing. And that's pretty much it for this talk. Props go to Matt Hillman and Nils, squidgy surname at previous employer. They kind of started me on the dtrace route, and when they told me about dtrace, my kind of mind was blown, and it took a very long time to sit down and figure out that actually it did work how they said it worked. Martin, Oliver at GDS, and GDS for giving me the time to research the project. We're currently writing a tool that's going to collate all this kind of agent-driven data into a common server and represent it all conveniently within burps as an extension. There are various problems to kind of get over before this goes live as remotely usable, but we are in that process at the moment. And last of all, thanks to BSides 2014 for giving me a chance to yak at you. Thank you.